Welcome to Custom Prototypes. We are a service bureau providing prototyping services in Toronto, Canada. We've been doing it for almost 2 decades by now, and recently we acquired several SL600 machines, and I would like to show you this equipment. Those machines are manufactured by Z-Rapid Technologies out of Suzhou in China. And as you can see, those are large platform commercial stereolithography machines which produce parts by solidifying photosensitive laser with a laser beam. As you can see, this machine has a very large platform, 24 inches by 24 inches in XY axis. The Z-axis is about 16 inches in this machine. The vat is quite large, about 240 kilogram of material. This makes the machine quite heavy. It's about, totally, it's about 1 ton. And another contributor to this weight is a solid granite block, which actually holds the resin vat. The reason the block is here is to actually keep the machine steady. We know that if the resin surface is steady all the time throughout the process, the quality of the finish of the parts is better. There's many shops where those machines operate, where we have where you can experience a residual vibration in the floor. Like, for example, in our shop we run several CNC machines as well as some vacuum pumps and compressors. This machine takes it all and makes sure that we don't have any interference with our process here. So because the machine is so heavy and because the resin is held in a solid granite block of material, we have a beautiful, nice finish of the surface of the parts. This block also serves as a base for the drives on which the recoater works. This particular machine doesn't come with exchangeable vat, but you can easily drain it. We run Somos material in this machine. Somos material is sold in 10 kilo jacks like that. And we simply pour it inside the vat and then control the level on the screen of the computer. The laser compartment is here on the top. It's a solid-state laser manufactured by Ingu Manufacturing. The beam is controlled by a scanner manufactured by ScanLab Technologies out of Munich, Germany. The diameter of the beam is about 0.1 millimeter. This is what we run at. As well as the standard definition is about 0.1 millimeter. This is what we use most of the time. Obviously, the definition can be changed, the resolution practically as much as you want. So if we want higher resolution, we go at 0.075 or 0.115 or so. The laser is controlled by this controller here, independently from the computer, although obviously it's working together with the computer. The control department is here, mostly Omron controls, all the sensors and switchboards and stuff like that. As of the software, this is also developed by Z-Rapid Technologies. It's called Zero. Our version is 4.1. It takes SLC extension files. What does this mean? That it doesn't simply take your STL file as normally. You have to actually process the files first before you load the machine with the files. So we use a third-party software for this purpose. In our case, it's Materialize Magics. This software slices the parts and also builds the support automatically. It's again very easy and fast software to use. It takes us, just a couple of minutes to prepare a part to load the file on the machine. This machine also has most of the parameters controllable by the user. So if you want to change the speed of the recorder, or the laser speed, or the hatch speed, or the parameter speed, everything is adjustable. So it's up to you how you set it up. Of course, there are some guidelines how, in the manual how this is supposed to be done, but since we've been running this machine for some time, we like to have access to those parameters, and they're quite easy on the software to be accessed. We have, as I said, this is a clear material here. It's almost watershed, so those are the samples of the product we can make. We can also dye it to different colors. That's, as you can see, Coke bottle printed on this machine. Let's move to another machine which actually runs right now, so I can show you the pattern and tell a little bit more. This is our second SL600 machine. We are running right now a small short-run production. We have about 50 pieces being made at the same time. You can see the layout here on the screen. So this is the actual cross-section which we are doing right now. So there's lots of hatching. Whatever is this solid area, this is a solid material. We are about half throughout the build, about layer 70 out of 169. The Zero software runs in Windows environment. In this particular machine, we run it in Windows 7. And this being said, we were able to hook up this computer to our network, and as such, we have an access to this computer remotely. So we don't have to be in the shop to actually see what happens. So we also have a camera inside. This machine is right now online, working, producing some parts. The camera allows us to see what happens inside. Again, we can monitor it from the mobile devices we have. To show you the process, here it is. You can see the blue laser on the surface. Right now we are hatching the surface. Those are little boxes, and right now we're making the bottoms of the boxes. The laser runs about at about 6 meters per second. The hatching process is not just single line, it's actually a 5 kilohertz zigzag to improve the hatching speed. The Ingu laser, which is inside, is of course solid state laser, 354 nanometers wavelength UV light. The material we use, it's this particular material in this machine, it's Somos Next. We love this material. The customers are actually addicted to it. It's very, very good, durable material, all-purpose material. We produce parts which are flexible, thin wall. This bottle, it's a 0.5 millimeter wall bottle, detergent bottle, which we produced here. Nice definition, a little bit on a thicker side, so it takes us a little bit longer to wash it, but the physical properties of the material are excellent. We actually compete with our SLS system, where we produce nylon parts. In lots of cases, we actually prefer to produce the parts here on this machine than in SLS process. So as I said, this system which we have of monitoring with the camera and computer being in our network so we can access it remotely prevents us from producing bad parts. Sometimes when we have a large, let's say 40 hours build in the machine running over the weekend, we don't want to come here, so we can actually check what happens with the machine from the comfort of our home. and we can not only change the parameters, but we can shut down the machine if there is a spaghetti carbonara in making. I'm sure that many of you who run this type of machines, SLA equipment, you went through this kind of troubles, and you know how much aggravation and time and the resources are being wasted when something like that occurs. Thank you for watching. If you have any more questions, please refer to our website, which is at the bottom of the screen. Hopefully we will be able to answer and help you. Thank you.